All right, so the number one thing that algebra and algebra 2 students seem to have an issue with is factoring. Okay, and I think the best way to go about this is to start, instead of factoring, we're going to go ahead and have a problem here like x squared plus 10x plus 21. All right. When we factor something, most students know the rules here, which the rule is we're looking for two things that multiply to be this number here, 21, but also add together to be this number here, 10. Okay, but why is that actually the case? So we're going to start this by working backwards. Okay, so if I had something like this written out here. Okay, I've got two binomials. Binomial meaning I've got two terms here and I've got two terms here. So each of these is a binomial. Now, if I was to FOIL this out, which FOIL, most kids have heard at this point in their math, which this would be first, outer, inner, and last term. So I would do my first term times my first term. I would do the outer term times the outer term. I would do the inner term times the inner term. And then finally, I would do the last term here times the last term here. Okay, so what happens when I actually do this? Let's start with our first. So with the blue here, I have x here times x here. Sorry, it's red. So x times x. And what's that going to give me? X times x is going to end up being x squared. Okay. Now let's do the outer term. Outer term, again, being x times my 7, and that would be plus 7x. Okay, then my inner term. Inner being my 3 times my x here, which I've got in green. So we'll do plus 3x. And then my last term would be, my last here is 3, my last here is 7. So that'll end up being plus 3 times 7, 21. All right. Now at this point, I need to combine my like terms. Okay, so if I take a look at this here, I have an x squared out here, and there's no more x squared anywhere in the problem. So I can't combine that with anything. But I do have a 7x here and a 3x here. Those are like terms. I can combine those. And then I have a 21 out here, but nowhere else in here do I have just a number. So that's not a like term with anything else. So what can I do at this point? I'm going to keep x squared here. I'm going to go ahead and combine my 7x and my 3x to be 10x. 7 plus 3 is 10. Keep the x with it. And then my 21 out on the side here doesn't have anything to combine with, so I'll add 21. And that would be foiling this problem up top to get to here. Okay? Now, what if instead of foiling, I was asked to factor this problem? Well, if I'm asked to factor the problem, let's think about the FOIL again. Okay, what actually happened up here with all of these terms? Well, to get this 10x here in the middle, I had to add 3 and 7. To get this 21 here, I had to multiply this 7 and the 3. So factoring, I'm actually going to work backwards from the FOIL that I originally did. So the first thing I'm going to do is I know that the second two terms here, 3 and 7, I need them to multiply to be 21. So when I'm factoring, the very first thing I should do is I should look at this last term right here, which in this case is 21. And what I want to do is figure out what terms or what two numbers will multiply together to give me 21. And in this case, I could do 21 times 1, or I could do 7 times 3. And that's it. There's no more options here to give me a 21. So now I need to take a look at my factors here. 7 and 3, 21 and 1. And I need two of these to add together to give me my 10, just like I added together the 7 and 3 up here to give me my 10. Okay, so we already know the answer to this because it's up top here. This is what we're going to factor out to get. So if I go ahead and look at the bottom here, I can say I know that the two factors that I need, it's not going to be 21 and 1, because that would add together to give me 22, and I'm looking for 10. Okay, so I'm going to pick the 7 and 3 here, because those add together to give me 10 and multiply together to give me 21. Okay, so those are my two factors. Now let's take a look at this. Factors mean when I write this back out, I'm going to have x and x both in two binomials. But what number do I put with it? Well, it's the two factors that ended up multiplying together to be this number and adding together to be this number, which in this case is 7 and 3. So I can do an x plus 7. I can do an x plus 3. Now, if I'm asked to factor, this is done. I don't need to do anything else. Okay, if you were given this problem right here, and I'll highlight it for you. If I was given this problem right here, and I was asked to factor it, okay, this problem asked to factor, all I'm doing is looking for what two terms multiply to be this, add together to be this. Now, it is important to note that the x squared here does not have a number in front of it. Okay, we can only do this rule if there's nothing in front of x squared here. Okay, that's why I end up with x and x, because if I went back to my FOIL, x times x is my first, will give me x squared. Then again, if I go to the outer and inner, so outer would be x times 3, inner would be 7 times x. That's going to give me my 10x here that I add together. And then my last term, L in the FOIL, will be 7 times 3 to give me 21. This is where I want to end up when I'm factoring. Okay? So now, why is this a thing in the first place? Why are we even doing this at all? Well, because typically what we end up doing here is we have an x squared plus 10x plus 21, and instead of just saying factor this, they say this is all equal to 0. And then they say solve for x. Well, at this point right here, it's pretty difficult to solve for x. Like, I don't know what I could plug in here. I could just randomly plug numbers in and eventually figure it out what's going to make this equal 0. But if I factor it, it's going to make it much, much easier to solve for 0. Okay, why? Well, let's take a look. We already factored this, and we got x plus 7 and x plus 3. So let's go ahead and write that. X plus 7 and x plus 3. And we know already that all of this factored is this. So this whole thing here is the exact same thing as all of this. Okay, so then we'll just finish here and say it equals 0. Okay, now, next rule. We already know, you guys know this from before, anything times 0 equals 0. So, I mean, it doesn't matter what we have here. If we have 10 times 0 is 0, we have 27 times 0 is 0, anything times 0 is 0, and we know that. So let's go ahead and take a look at why our factoring here is important. Well, if I look, I really have something here times something here. So as long as one of these binomials is 0, my answer will equal 0. It doesn't matter what the other thing is. So let's take a look at this one over here. Okay, let's start with x plus 7 equals 0. So we're just making, again, this whole thing here equal to 0. So x plus 7 equals 0. How do we solve this? We subtract 7 from both sides, and x equals negative 7. So let's take a look here at our formula. If we plug in negative 7 here, so negative 7 plus 7 is going to be 0. So now all of this parenthesis here is 0. Okay, this one over here, it's going to be negative 7 plus 3, which is negative 4. But I don't really care what all of this is. And why I don't care what this is because this is 0, and 0 times anything is still going to be 0. So this is a good answer for me. X equals negative 7. Okay? Now, I can also do the same thing with this term. And I'll keep this in blue here. So let's say instead of working with my x plus 7, let's work with our x plus 3. So if I said x plus 3 equals 0, I can do the same thing here, subtract 3, and x equals negative 3. Okay, now let's look back up at our problem here. If I just focus on this one here, okay, and I plug in to the equation for x here, if I plug in negative 3, well, negative 3 plus 3 is 0. So now again, all of this is 0, just like I did over here. And since this is 0, it does not matter what this is. We can go ahead and do it if you want. This is negative 3 plus 7 would be 4. But again, I don't really care what this number is because as long as this is all 0, 0 times anything is 0. So I would have two answers here, and they would be x equals 7 and negative 7 and negative 3. So factoring, let's go back up to the whole concept of this. I've got a problem like this right here. X squared plus 10x plus 21. What am I looking for to get this to be factored? Two things that multiply together to be 21. So go ahead and make a factor tree here. Start with 21, and even if you need a calculator to just start and say 21 divided by 1, 21 divided by 2, 21 divided by 3, 4, 5, and you don't know what it is, go ahead and just figure out what terms give me another whole number. Okay, and then you'll end up with a couple different options here. Whichever ones add together to give me this middle term, those are going to be my correct terms. So in this case, it would be 7 and 3. 7 plus 3 is 10. That gave me my middle term here. Then I'm going to separate this into x plus my first term and x plus my second term. Now from here, the reason we're doing this in the first place is most of the time it is not just factor it. Most of the time it is solve for my 0, which again, in this term right here, it would be difficult to just figure out what numbers I could plug in here and here to give me 0. But if I factor to this, now it's pretty easy to figure out what terms will give me my zeros. I can set this up equal to 0, like I did here, and I could set this up equal to 0, like I did here, solve for my x's, -3 and -7, and again, as long as one of these binomials here or here equals 0, then my answer will be 0. Thanks for watching. If you got any questions, go ahead, leave them in the comments. If you need help with anything else, feel free to leave that in the comments too. I'll try to get back to you as quick as I can. Thanks.